Okay, so this is a clip for the first problem in the 1-3 rate of motion acceleration discussion. So we've got a problem where a car accelerates on a straight road from rest to 75 kilometers per hour in 5.0 seconds. What is the magnitude of its average acceleration? Okay, so we're going to follow our standard procedure. We're going to start with our frame of reference or our motion diagram, and we're going to collect the information, and then we're going to figure out what formula we need and then solve it. Okay, so here's our standard frame of reference with an origin and the positive x values, and we're told that we go from rest to 75 kilometers per hour, and so we're free to say that our initial position is 0 meters. We're not given any information about how far we do end up going. Okay, we could figure that out if we wanted to, but we're not asked to. And then we are told that we start from rest, so our initial velocity is 0 meters per second. Then we're told that our final velocity is 75 kilometers per hour. Now we have a little problem here in that for most of our problems we need our velocities and our displacements and accelerations in meters rather than kilometers, and meters per second rather than per hour. And so we have a trick. Let me just show you why this trick works. So let's say we have 75 kilometers per hour, and we want to change that into meters per second. Okay, so my strategy for these is that I start with one value, I start with one unit, and I say I want to get rid of this unit. What do I want to change it to? Okay, and so usually I can do this in one conversion. I want to get rid of kilometers, so in order to be able to get rid of kilometers, I put it on the opposite side of the dividing line, and that way it'll cancel out, right? Kilometers cancels kilometers. And then I want to add in the unit I want to create. I want to create meters, and I know I have a conversion between meters and kilometers. So I can say 1 kilometer is 1,000 meters. Okay, and then I want to get rid of hours, so I'm going to put hours on top here, so that'll cancel out. So I just put it on the opposite side, and then on the other side I want the unit that I want, so I'm going to put in seconds. Okay, that's what I want to create. And so now I'm going to say 1 hour is 3,600 seconds. Okay, so really, in order to get from kilometers per hour to meters per second, all I'm really doing is dividing by 3.6. 1,000 divided by 3,600 is dividing by 3.6. So if I want to go from kilometers per hour to meters per second, I divide by 3.6. And I can reverse this process if I want to go from meters per second to kilometers per hour. I just do the opposite, and I'm going to multiply by 3.6. So this is our standard trick. Okay, commit that to memory. Now, I want to change velocity from kilometers per hour to meters per second, so I will just divide by 3.6, and that gives me 20.8 meters per second. Okay, so I go from 0 to 20.8 kilometers or meters per second in whatever time it is that this is going to take me. And then I need to put in my acceleration. I know acceleration is going to be in the positive direction because my arrows for velocity are increasing in length in the positive direction as well. So I'm going to say A equals, but I don't know what it equals because that's what I need to find, right? So given x0 equals 0 meters, I don't know what x is. V0 equals 0 meters per second. V equals 20.8 meters per second. And then I need A. And my formula is just going to be my standard acceleration formula. I've got V and V0, so I can say A equals delta V over T equals V final, my final velocity, minus my initial velocity over time. And I know my initial velocity is going to drop out. Let me get rid of this stuff here. We don't need that. And then I'm going to solve. All I need to do is plug my values in and solve. And so A equals, and V is 20.8 meters per second. And I'm going to divide by the time. Oh, I forgot to put time in my given, 5.0 seconds divided by 5 seconds. And that equals 4.2 meters per second squared. Okay, so that's the answer to this problem. Go ahead and go to the next one.